Welcome to this episode of Tech Talks, where we dive deep into the latest innovations in technology and artificial intelligence. Today, we're discussing an exciting new development in the world of language models, known as EM-LLM, or Human-Inspired Episodic Memory for Infinite Context LLMs, a project that offers impressive capabilities in processing and recalling vast amounts of information. Let's start with a big question. What has been the main challenge with standard large language models, or LLMs? Well, these models typically struggle with extensive contexts. They can only remember or process a certain amount of text at a time, which can be quite limiting, especially in tasks where understanding a broader narrative truly matters. But here comes EM-LLM, which takes inspiration from human memory. Imagine your brain being able to seamlessly recall events from years ago with incredible precision. This is the essence EM-LLM aims to replicate. So what's the secret sauce behind EM-LLM? It's all about structuring information like our brains do. EM-LLM organizes sequences of text into coherent episodic memories, using clever techniques from areas like Bayesian surprise. Yes, it's as interesting as it sounds, and graph theory. This allows the model not just to remember, but to retrieve information in a way that's reminiscent of how humans recall stories from our lives. Let's unpack that a bit more. Think about how you remember your last vacation. You might recall specific events or moments that stood out, right? EM-LLM does something similar. It groups tokens, basically pieces of text, into what it calls episodic events. This grouping is refined in an online manner, meaning as it processes more information, it learns to create better representations of these events over time. Now you're probably wondering, how well does this work in practice? The results have been impressive. In tests against other models like InfLLM, EM-LLM didn't just hold its ground. It actually outperformed them across various benchmarks, handling tasks that require remembering vast amounts of information, thousands of tokens long. To put it simply, while conventional models might struggle at this scale, EM-LLM thrives. But let's not just throw around technical jargon. Here's where it gets really fascinating. EM-LLM doesn't just excel in raw performance. It connects the dots between artificial intelligence and human cognition. The analysis shows a strong correlation between how EM-LLM segments events and how humans perceive these events. It's like creating a technological bridge that can help us understand not only AI better, but potentially human cognition itself. And how does EM-LLM actually work in terms of architecture? The memory formation and retrieval system is quite complex, with multiple layers designed to segment input based on certain probabilities and refine those segments for better coherence. It retrieves information by combining different approaches, ensuring efficient access to relevant data points, almost like having a super-organized filing cabinet instead of a messy desk. Now, as we wrap up, isn't it amazing to think about how technological advancements in AI could unlock new ways of understanding human memory? EM-LLM is a perfect example of that synergy between biology and technology. So, what's next? Imagine if further research could lead to even deeper insights into our own cognitive processes, or how this kind of memory system could be utilized in real-world applications. Let's contemplate this. If we could significantly improve how machines remember and process information, what new functionalities could we unlock? How might this change the way we interact with technology in our daily lives? Thank you for joining me in this exploration of EM-LLM. Remember, as technology evolves, so do our capabilities. Keep questioning and stay curious. Until next time, take care.